Hey guys, so I updated MockMechanics to remove some of the bits that weren't working, like visual programming. Now we can use actual JavaScript, and I actually imported it to Blender so that the modeling is done in Blender, so you have complete flexibility, and then the parts that are good, like the graphs and the tracks and the axle work still work. Here we have creating a wagon in Blender so that things move in a path. You can see set the value there. And if I duplicate this and put it over here, I can create an axle. If I rotate, it's gonna rotate in the wrong direction. But if I move the axle direction like this, yeah, now it rotates. It's off center, but still. Let me fix that. Close enough. Yeah, rotate like this. Let me change the materials because we're going to export this. Let's export to the folder. Right, here I have just a hello world threejs, just a world where I can load things. Now, if I load the library that I wrote to be MockMechanics, and I initialize it, I pass a few things that it needs, like the scene and the camera. And I load the thing we just created. There. Let me move it up a bit. Hold on. Yeah. Too much. Okay. When I press a key, I want to be able to do things. Yeah, it's working. Okay, now let's yeah, it's working. Let's run the wagon as a graph, because you can create a graph and run the wagon as a graph. At time 0 it should be 0, and at time 1 second it should be 1, which means at the end of the path. So if I run it, yeah, I have to create a few. I have to give access to a few functions to update the MockMechanics library and pass the mouse events and so on. See, at time 0, at time 1, it's now. Let's do it slower at 3 seconds. There you go. Let's go back to 0 at 6 seconds. So it goes at the end, then comes back. There you go. Now let's run the axle to test it as well. By the way, the parts that you create on Blender with the name like axle or wagon, you can just access here, like part.axle. It just works. See, it works. Let's only rotate halfway at 2 seconds, and then rotate back at 4 seconds. On 180 degrees, then back. Good. Let's do both at the same time. Right. Okay. Now I want to test a probe, which is a way to test if a part is in a certain position. So I create a new part here to serve as a wall, and I'm gonna add, let's set the cursor to the face there, and let's add a probe with these two objects. If I rotate this, you can see one probe follows the white object and the other stays at the wall. The point is you can detect when those two probes over there are close to each other. Let's export again. And now I can test if the probe is 1 or not, if it's true or not. Right now it should be. Yes, it is. If I test this and rotate the I do one if the probe is true and the other if it isn't. Yeah, except I did it the other way around. I want to move the axle so the probe is not triggered after it runs once. So let's move this here and the other there. First time the axle will rotate, but the second time the probe is not triggered, so the other thing will move. See? And from now on it won't move because the probe is not triggered anymore. Okay. So let's create the Rubiks Cube. Let me create an object here to serve as the core of it. And I'm going to divide the 3 faces. Let me duplicate this and separate it to serve as one of the faces. Let's change the materials. This is the right face, okay. Let me put the cursor on that face there. And now I'll put axle right there. Let me change the direction. Now the face can rotate like that, okay. Let me remove this stuff. Let's change that to the new object. Too big. Let's change the scale. And move it up. Good. Right. Now I can move with the mouse. The problem is it's not snapping to 90 degrees every 90 degrees, so I need to use this function to limit the values. The axle should be every 0.25, so it snaps at 90 degrees. Good. Now, let me put the cursor here and let me create an object to serve as one of the little pieces that the face is supposed to move. Later I'll change it to the colored pieces. For now it's just a blue cube. So the face rotates, but now I want the blue thing to move with the face. I can load the Rubiks code.js, and whatever is in here will automatically work. You'll see what I mean in a minute. This function, for instance, is called whenever the cube is pressed, whenever any part of the cube is pressed. See? It prints cube press. Now, I want to find the blue part. Ignore this thing. I'll change that later. Yeah, but it's the part, the blue part. The face is the name I put in Blender, right? This sort of worked, but the blue thing moved. I think, yeah, that's the better way to do it. That way it keeps the original transform. See? It attaches and it moves with the red. Now let's let me just change the rotation here so that I can duplicate the face to create a different face. Let's change the material so we can see it properly. And yeah, that rotates fine. Now it rotates as well. It's still just dragging, only moving with the red face. Let me change the green one to front. Let's see if I can make it move with the front face. It's not moving yet. Besides, it doesn't have the snap points. Let me add the snap points for the front face as well. The axle is called axle 001. You can ignore the dot. Yeah, it snaps. Instead of, let's use the front face to see if it moves with the green face, the front face, which is green. Yeah, it does. Now, let's see. Let's remove the actual faces because I don't want this interference here. There, I can move like that. The trick now is to find which face should move the blue thing. So when I click a face, it prints the direction in XYZ that the face is in by just printing the position of the socket. What I want here is all the pieces that happen to be in that direction relative to the cube. So in this case, the blue cube, the blue test piece is on the, let me move it to the right place. Let's name it piece 000. And the position is for all the pieces named piece something. Yeah, let's move it to, hold on. Let's make sure everything is working. Yeah. No, hold on. Yeah, piece 0. So just traversing the whole scene to find the pieces. This is the piece, and this is the position. I want to find the global position of the piece. There it is. Oh, I have to use the MMD. Actually, I want the relative position between the piece and the cube. This code there should do it. So the piece position relative to the base. It's let me move it to a more sane position. 1, 1, 1. Actually, I want the y to be -1. In Blender it will be y -1, but in threejs the coordinates would be 1, 1, 1. Well, 168, whatever. Now, if I rotate either of those faces, it should grab the piece because the face has a component in common with the piece. The red one has x equal 1 and the green one has y equals 1. So in this case, if I did this little code here that prints the whether they have anything in common, turns out it's just the dot product. So if I compute the dot product between the position of the piece and the face direction, it should be 1 if the piece is in that general direction and it should move. Let's remove some of this stuff. Yeah. So basically, let me change the name here, I'm making an array of things that I want to move. And I'll compute the dot product. And if it's greater than 0, then I add it to the moving array. And then I don't think I need the array. Hold on. If I grab the red, Yeah, if I grab the red, it moves with the red. If I grab the green, it moves with the green. This is another function that gets called automatically. I want to, when I first load the part, I want to make the actual pieces, like the blue one, unclickable, so I can click in the face that's underneath it. Yeah, like that. Now let's load the actual model of the cube. I made this another time to have the right pieces. So let me delete the white stuff that I don't need. And the name is wrong. Let's just rename them to piece 000, piece 001, and so on. Right size first. Yeah, it's fine. Piece 000, right. Piece 001, and so on. Right. It sort of works, but there's problems. Yeah, that's part of the problem. I have to use an array, because if I move things, then the array is better. Still a problem there. Something is moving. If that is not working, it's because the test that we are using, the dot product there, is not working. Let me test for this one piece, which is wrong. Oh, I see. It's because it's not quite 0. Now it should move, not move. Okay. Good. I only have these two faces, so okay. Now I hid the faces. I still have the shadow though. I hid the faces. Let's see if I can hide the shadow. Perfect. Let me move the pieces to a new collection just so I can hide them. And now I have to create the other faces. Okay, now I have all the faces. Hold on, I have to create the snap points for all of them. Actually, I can move this to the init function as well to keep the cube well contained. Move this here. Do this for the other faces as well. Let's see. Yeah. Yeah, it snaps. Cool. Now let's create a function to scramble the cube, just for fun. Let's scramble the cube when I press a key. If I press S, it calls the function from the cube. Yeah, this thing, I'm gonna remove it. It's confusing. Object has the cube itself, the part you loaded, so you have access to it. Since I'll have to attach pieces to scramble, like attach, rotate, then attach to a new face, rotate, let me move the attachment to this new function. And then I can just use it when I press, because I'm rotating the face by hand. Yeah, it works. And now I can pick a face. For now, let's just pick the front face. And the axle is just the parent of that face. They attach the pieces, the relevant ones. And then let's run a graph that rotates that face by 90 degrees. So at 0, it's at a value 0, and at, let's say, 1 second, it's at 0.25, which is 90 degrees up. So if I rotate, it rotates 90. But it only rotates from 0 to 90. Yeah. Let's create a button to rotate the face instead of doing it by pressing a key. So let's create the base of the button here. And a cylinder to be the cap of the button. Let's add a little bevel here to make it look nice. Hold on, it has to be apply the scale. Little bevel here. Scale. Yeah, that's fine. Now let's make this black. Yep. And let's make the cap red. Okay, the modeling is done. Now let's implement the actual degrees of freedom of it. Let's put the cursor there. And let's create a wagon so it can move up and down. Yeah, but I need to move this down so it moves in the right way. Too much. Yeah. So when value 0 is unpressed and it's 1, it's pressed. Okay. I also need to add a probe to make sure I can detect the press. So let's put the cursor here, right beside the cap, and let's add probes there. Yeah, but right now it's detecting when it's unpressed. I actually have to move the probes, create the probes when it's pressed. So same thing, and add the probes again. Right, so when it's pressed, the probes are near to each other and I can detect the press. The button is done. So export it as button.glb. Export it. Now let's load the button here. same as the cube, so just load it. And let's move and move to the side there a little bit more. Actually, I don't want it, I want it to flush with the ground, so let's move it in the model here. There. And export it. I don't have to move it there. If it's 0, 0, 0, it should sit on the ground. Right. Let's scale it because it's too big right now. Not so much. No, it's fine. 0. Yeah, right now I can move it up and down, but that's not what I want. I want to press it and it goes down. So first thing I'm going to do is open the button code file, and I will disable it to move by pulling with the mouse. So let's give some names here. Base cap. Let's lock the wagon so it can't be moved with the mouse. See, it doesn't move anymore. Now, let's create a function. When I press, it goes down, and when I release, it goes up. And then I can just run a graph to make it move down. The wagon at time 0, it should be 0, and at time 1 second, it should be 1. And then when I release, it should be the opposite. At time 0, it should be 1, at time 1, it should be 0. Let's put a smaller time. Let's say 0.2 seconds. Then I press it, it goes down, and when I release, it goes up. Right. It works as a button now. Now, I have to detect the probe to actually do something with the button click. So, on probe, and then I just scramble it. Well, let's test it first. Yeah, the button press works. So let's scramble the cube. Nice. Now, let's improve this scramble code. Let's list all the faces here. And let's pick one at random. That's it. It's not too hard. I created a cube and I create the button to scramble it. That's it. See you in the next video.